Hello, everyone. Welcome to Bird Process Equipment's educational webinar on containerized systems. I'm Mark Dragenti, the Director of Design and Engineering for Bird Process Equipment. And with me today is Madison Mulkey, one of our fellow design engineers. I want to welcome everybody to this webinar, our last webinar of 2023. Just a few things before we get into the subject matter. Feel free to ask questions into the chat window. We will be taking questions throughout the broadcast, and we'll answer any questions at the end of it, as well as answer any emails if we don't get to them during the actual live broadcast. There will be a couple of poll questions posted throughout this webinar. They're totally optional for you to complete. They're just kind of highlighting some of the key educational points that we're going to cover today. Also, we'll send out some surveys at the end. Again, completely optional. We're always interested in the feedback of our clients and what webinars and additional content you'd like us to cover as we start planning our webinar series for 2024. So today's topic is a little bit different than some of the other ones for any of you who have followed our webinar series. Today we're talking about not so much a different type of system. We talk a lot about water treatment systems. We talk about pH. We talk about high purity water. We talk about chemical feed and process lift stations. Today we're talking about a different way to essentially build these systems, and that is a containerized based system. So what is a containerized system? Containerized systems are essentially a self-contained unit. So beyond what you would typically associate with like a cabinet or something that would be located inside of a building, these are essentially taking a skidded process system, whatever that system might be, and fully fabricating it into its own standalone module, whether that's a shipping container or some kind of other outside device that includes the utilities, environmental protection, lighting, and a lot of the different features that we're going to cover as we go through this broadcast. So they're completely standalone. So it's a little bit of just kind of a different way to approach these systems. And there's kind of a lot of history behind sort of where these came from. For a long time, people were building outside buildings if they needed to, but now you have contractors, you have permits. This is kind of a way to sort of build the system and integrate it into your plants without having to go through all of the sort of, normal major construction steps. So what's the advantage of doing a containerized system? Really, there's minimum to no downtime on existing processes. If you're working as a design engineer, if you're an end user, a lot of people, we have a project, we have to upgrade a system, the system's in some sub-basement, there's effectively no access to it, or it's going to require shutting down other parts of the plant while you do that. Building a system into more of a containerized or modular design like this allows you to essentially prefabricate, pre-engineer the entire system ahead of time, bring it to the facility, and then just make a simple tie-in into the system. So there's really no impact. There's not a lot of on-site construction work required for these kinds of systems. There's no need to be rigging things, through openings if you have existing areas or knocking down walls. It saves a lot of interior space. And depending on what you're trying to do type of system, we'll talk about a couple of those in a few minutes, it can be very beneficial to segregate different forms of, different things that might be going on, such as hazardous waste. And it can be implemented very quickly. Containerized systems, they were a thing sort of before the pandemic of 2020, and they really grew in popularity, in the early days of the pandemic, because they allowed you to, put in a new piece of technology or new piece of equipment without having to have people in the building, without having construction, without having to, interface with that. And one of the other ways that these types of systems came about was the advent of sort of portable labs. And, there are companies out there that make like portable clean rooms, for example, and some of the first sort of modular containerized systems were tied into portable clean room devices as well. Portable clean room laboratories. So there's kind of the bit of the history of sort of where this really came from. And as this, and now obviously as we're kind of moving forward, it's a really nice feature to have on certain projects. So what are the different types of containers that can be used? And the other important thing is, depending on where you are, this is not considered a building per se. So it's not a permitting, it doesn't require things like that. Most of these are modified storage containers. Um, you take a modified shipping container, whether it's a 40 footer or 50 footer or 20 footer, and you can basically outfit it. And we'll see a lot of examples as we go through the presentation today of what that kind of looks like. Structural cabinets to be located outside of the building. There are small, as I mentioned, modular or basically modular clean rooms is also an option as well. So what are the different types of features that are available? Obviously, most people think of a shipping container, they're not envisioning what you kind of see in the picture there. And that's really what you're doing. You're taking just that outside structure that you need and you're outfitting it into the system that that's required. Where you have chemical resistant writing, you can have full environmental controls. You have HVAC for both heating and cooling. There can be drains, ventilation, insulation, utility outlets, multiple access door options, which is often a requirement for these types of systems because, depending on how they're laid out, which we'll sort of see in a few minutes here, you do need to be able to access different areas. And again, there's also a lot of different assorted ranges and sizes that can be utilized with these systems. So what can be built into a containerized system? Really anything can. These are obviously some of the things that we as a bird process manufacturer, and a lot of them do obviously handle water, water technologies, pH neutralization, filtration, high purity water, solvent collection is kind of some of the big ones, as well as chemical feed-based systems as well. So this is kind of our first look inside what really one of these types of containerized systems, is. And you can see, looking at the model here, you have multiple access on sides. You have emergency exit doors in the center there. And you can see how these are essentially, for those of you familiar with sort of multiple skidded systems, that's really the layout that you have here. So this is a pH neutralization system, which we'll talk about in a couple of minutes. You can see how you have the two larger modules, you have the access in between, you have the full chemicals, you have the control setup, you have access around it. You can see where there's the lighting and the access hatches for access to the top of the tank. And this kind of gives you sort of an overall idea of sort of how these systems are sort of largely kind of laid out. You can even see in the picture here, if you can follow my cursor, some of the trench drains as well. For the collection of any leaks that might be involved in the system. So I think kind of the best way to sort of approach this is to look at kind of a couple of different case studies to kind of see, what types of systems go in, what are some of the features that are looked at in these types of systems. We're going to focus really on sort of three different ones, specialized chemical feed, chemical waste collection, as well as pH neutralization systems. But before that, we're going to have our first poll question, which you can post on the screen now. So the poll, kind of an obvious one here. What are the different advantages of making a containerized system? And the answer, of course, is all of them. Minimum to no downtime, no impact. Space interior savings, and then can we implement it quickly without any major a lot of major construction costs associated with it. And that's really the benefit of containerized systems. Yes, one of the things I kind of want to say up front before we go too much further is a containerized system has, from an equipment perspective only, a higher upfront capital cost. Obviously, if I just took a system and I put it on a skid and I shipped it, that's obviously has cost A. Once you do this type of modularization that we're seeing here, you do have that sort of increased cost associated with it. However, what you're removing is a lot of that construction cost that goes along with it in downtime costs. So, from kind of a return on investment perspective, very often it's actually, a positive to do this. Um, and you're going to see some of the pictures later. It's not like you have this sort of big ugly box or something outside of your building that's, very hard to look at. So that's one of the things people ask a lot of times is, well, what is the cost and impact to do this, say traditional skid? And yes, there is this, financial investment to do this, but you do save a lot on some of that back end, if you're doing budgeting on a project, for example. So one of the most common things that's put into a type of system which is put into a containerized design is a chemical feed system. And the reason why chemical feed systems are done often that way is because a lot of times they have to be put or they're actually needed in somewhat remote or outdoor locations. So a chemical feed system, for those of you unfamiliar with it, is a process by where you transfer in one or multiple different chemicals into a stream or into a tank. And these are used in municipal, wastewater, food and beverage, any kind of large plant scale. For example, we can just see some of the features here of the unit. You have the metering pumps, you have some of the back pressure regulating valves. But because of what their usage is, it's very often common for these to be located, outside of the plant environment. And you can see one example here where you have, and these are generally much smaller than the examples I was just kind of showing you, some of the larger kind of shipping containers. These are more like hot box or even sort of modular shed examples. Here, this particular application was used in the oil and gas industry. A lot of chemical feed is used in the oil and gas for those who are involved on that, who is listening today, where you have a rig or you have outside environments. They'll put these in these kind of modular containers like this. These can also be hazardous duty, which is also very common, particularly, a couple of examples I've seen where they've used chemical feed for in more of a containerized design has been for fertilizer plants. Again, another area where you need to be concerned about their hazardous rating. And this is a very simple container. Obviously, it's a single access. It's basically just for HVAC protection of the actual unit. It isn't a large enough unit. In this case, you may have some kind of basic lighting involved in there because these systems are considerably smaller. A system like the one we're seeing here in the video, those types of units, you're talking about something maybe like a 5x3 modular, for example. So it's not always just a larger system that needs to be looked at as, that can be put into a system, because you can obviously scale down a containerized design, to something as small as a pump box effectively. Some of these also have access from different ways. So this type of containerized design is basically only side or top access, as opposed to having, say, multiple doors that you would see more like a shipping container-based design. And then there's obviously some much larger chemical examples. This one is obviously a stainless steel. This is for tote transfer, all to be located outside the building. Different venting options available for these types of units. These obviously scale a little bit larger. And we're going to see in a minute here, it's very common to have this type of design, particularly when you have hazardous-based chemicals involved. This one here is not a hazardous one, but there are examples where you want to put hazardous outside of the building that then allows you only to have to area rate, for example, just the actual containerized configuration that you're looking at in that case. And then you can really have very customized, containerized options, particularly when you're talking about chemical feed, for example. So in this picture here, you can see you can have like chemical safety showers. This one does have a full secondary containment. You can see the HVAC one on the right, hazardous placard indicators, storage tanks. This is another example you could see of a full system, which actually has the indoor storage tanks, the lighting, for example. They can even have things like fire suppression systems located in them. So rather than just having a basic tank farm and then having all this heat trace or insulated, chemical feed equipment outside of it, you can have this modular work area where the plant operators can go in, they can work safely. You have containment, you have real controls. And again, it can all be hazardous. In this case, you have also have hazardous location equipment located in this one as well. Containerized systems can also be mobile. It doesn't necessarily have to be a fixed item, and that's actually one of the earlier ways that I think I've seen these actually been utilized. This was one example here where these are actually built into more of a trailer-based configuration that could be utilized. This one, for example, is just for hydrofracking, for disinfection of the water that was utilized in those systems. You can kind of have the different access and different almost modular bays. This is kind of a way to build a system where you have all the features that you would typically see in a normal containerized system, but then you also have the benefits of having that, basically having that mobility. Another example, very commonly that I've seen people utilize is also on, like, for example, on power plants, for example, they build systems like this, which are fully trailer configuration, use the wash down turbines, for example. So don't just think, obviously, of a containerized system as just, kind of a fixed unit. There's a lot of different sort of customizable ways that these types of technologies get utilized, and they share a lot of the same basic characteristics.
Hey Mark, it's Madison here. I had a question for you at this point in the webinar. So for something like this with the hydrofracking, what would be the utilities included or the number of connections that would need to be made, the electrical, plumbing, venting for a containerized system such as this one?
Of course, and there's different ways to look at this. So when you're talking about more of like a mobile container here, these have a slightly different power connection. These would typically have a plug-in based power connection where you would have like a single 460 volt connection, and then within the actual container itself, you would have all the necessary transformers and everything else that would then power any lighting, utility outlets, things like that. When you're talking about more of a fixed base container design, really it's the same connections that you would need on a basic skid. You would need to have your power connection. Most of these are going to be some kind of a 460 volt, although not exclusively the larger ones, because you do have to power the HVAC as well from the system, which will then have its own base transformers at that point. You have venting. These are often vented either in outside of the container. And one of the things you do often see is a feature, depending upon what you're doing in these units, is you do have LEL or you do have air monitor sensors. Not that you necessarily require that, but because you are in an enclosed environment with a system, it's good to have that as well. And then you have your basic power, you have your basic, inlet and outlets, depending on what type of system you have. If it's a chem feed, you have your chemical outlets. For different chemical feeds that have storage tanks, they may have external feeds for the chemical to actually bulk fill them, which is kind of a convenience. You don't actually have to go into the container at all. That's one of the things, while you have all this access, one of the things you generally want to have is the most accessibility from outside of the container to not actually have to keep constantly going in and out as necessary. Just like you would obviously want to kind of work around the outside of a skidded system without having to actually go into the unit itself. Speaking of more in the realm of hazardous-based systems, here's obviously a few examples, again, kind of scaling these down. One of the other utilities, Madison, obviously, that I didn't mention just a moment ago, can be things like compressed air or nitrogen that you may see depending on what the nature of the chemical is. And hazardous is actually a very common. What I mean by hazardous, I mean any kind of fluid handling, whether it's transfer, storage, that's going to lead to an area classification rating, class 1 div 1, class 1 div 2, for example. And one of the reasons that these are very often containerized or modularized like this is to basically so you keep that segregated. You don't necessarily want to be having such type of chemicals inside your building in any large quantity. So you have things like drum connections here, for example, where you can just offload and inload these things without having to actually go into the buildings with them. And just really just kind of high level, what a hazardous, chemical is really anything that's, talking about your benzenes, your toluenes, really anything that could have potentially be a VOC chemical, for example. A lot of different industries utilize these types of systems, and this is kind of the real benefit of making them more containerized is even within the building, you'd have this as some kind of a containerized unit, but having the additional ability to put these outside, for example, is really kind of a big benefit for these types of systems. And these would have some different venting requirements. You may have integral conservation vents and things like that. They may have integral fire suppression systems as well, but allows you for easy access and only have to do that minimal amount of transferring in and out of your building space without having to put these types of chemicals, into your actual unit. And one of the bigger systems that I've seen utilized a lot, and I went through a little bit earlier in some of the the animations and stuff, that people have put into containerized systems is pH neutralization systems. And one of the reasons people do that is just how pH neutralization systems kind of really where they are in your overall building scope and process. Whether it's a public health lab, an industrial facility, a college, depending on where you're generating this waste, you have some kind of a waste diagram that's going to flow. It's going to flow down and then out of your building, through some kind of a subflab that's going to hook up to the city sewer. And at some point in that process, you need to intercept it. And pH neutralization is one of those things where it's needed, it's environmentally needed, but it's also not something that makes money. So people don't want to be taking up valuable floor space for it. You're already kind of exporting it out of the building in this case. So it's one of the ones which is really kind of a prime candidate. People are like, I just want to drop something next to my building and I want to just tie that waste line in or pump into this. And just kind of like sort of set it and forget it and then let it kind of drain back out into your building, into your effluent waste stream. And I think that's why pH neutralization systems is one of the more common sort of larger scale systems that you see built into more of a containerized based design. And that really goes kind of with really any industry that you have. The thing with the pH neutralization systems is they're a bit bigger than some of the other ones we were just kind of talking about. We sort of talked about some of the mobile units. We talked a little bit about, chemical feed, even some of the large ones that have some of those storage tanks in there. When you're doing a pH neutralization system, you have these large treatment tanks. You have, that basically required based on what your effluent flow is, and whether that's, 50 GPM, 100 GPM, scaling that up. And one of the first units that we actually did, this was actually kind of a valuable, this is the video that I'm kind of showing here, was actually divided into two different containers. It was built for a public health lab. It was fully redundant. You can see there's some of the larger tanks. So there was quite a bit of flow obviously involved in that. And this is where you kind of see how these things are sort of built and designed. You can see the access hatches in there. You can see some of the lighting that's utilized, the testing that goes into these units. Because in addition to making it a functional system, it needs to have that ergonomics, it needs to have that safety. You can see all of the white insulation back there, the safety outlets. But this is, and all you really have to do is just access this sort of front section there. You have your control set up. This is one of the more common sort of systems that we for process tend to do as far as container systems is these pH neutralization. You can see that's the full system there, and there's a lot there's a lot of benefits to doing that. You can kind of see here's just kind of a case study, a little bit of an example here. In this particular system, they had to break into two containers, even though you're going outside. real estate is still real estate. So, you have a large system, you have a 200 GPM, for example, at a large facility. There are limitations to how much you can put into a single container or modular container like this and still make it practical before you're essentially just building a building at that point to house it. And there is a time and place where you will do that, where you'll have an effluent wastewater treatment plant, for example, where you have that levels of flow. So it is important to know that there is a lot of different options, even in the realm of containerized systems, where they are kind of a fixed geometry, where you have 9 foot high or 8 foot high, 20, 40, or 50 footers, to sort of do that, as well as really interconnect these two types of systems, as well. Here's kind of a look inside. You can see, obviously, there's no access between the tanks. You need to have, on the sides, you have to have that access on both the front and the back of the unit. And all the various components, you can see in the pictures here, you have pH instrumentation, the chemical feed, all need to be accessible from parts of the container where you can actually access them. So this is what they really look like as kind of a base starting point. These two systems, as I said, they're actually tied together. They have a common. Other things you can see here, you have things like lighting involved with these systems. You can have beacons and effluent alarms. So you actually know what's going on inside the containers. Any kind of alarms. These can also have. These are the common things that people tend to see as part of these types of systems. Just from a high-level P&ID standpoint for this particular system here, this system was fed into a lift station. As I said, almost all effluent comes out of the building. So this is obviously located adjacent, pumps into an equalization tank. It transfers out, and then you have your two containers, 3,000-gallon tanks each. You can actually fit some fairly large tanks into a containerized system, 3,000, even up to 4,000 gallons into a single container. Chemical injection, here's your second tank, and then you have your shared effluent here. And this is what they look like. So you have full access around the system. You have that access here. You have your fire suppression. You have your controls. You have your full OSHA access. This is all your effluent piping, access hatches for the top, and then you have a back way here that allows you to actually pull the tank out for maintenance. So it's an important thing to kind of look at, and our engineers look at when we do these types of designs, is that ergonomics and that ability to access maintenance and remove any parts that may need to be replaced or serviced down the road as part of these systems. This is the mirror. This is the second one adjacent to it. This is your effluent trap here. These are some of your storage chemical cabinets as well. So your only primary access area needed is really in this sort of very small space here at that point. At this point, we'll do our second poll question. If anybody would be interested in taking a look at it.
Mark, in the meantime, while people are doing the poll, I had another question for you after this case study here. And the question is, are there different modular building options available if a standard container doesn't work for a particular application?
So yes, I'll address the poll question first. The question was, can really any type of system be put into a containerized system? The answer is true, as long as it's with any reasonable size. Obviously, as you can see here in this picture, as they're building the unit, the actual tank sliding in, there is a finite dimension, pretty much based on how much you can ship. You can start putting multiple containers together, and things like that. But there are obviously limitations once you get to a certain scale of magnitude where having a containerized design doesn't really work in those cases. which ties into your question, Madison, from the audience, which is there different options? The answer is yes and no. So there are sort of standard sizes if you're talking about more of using like a modular shipping container. There are people who actually make modular containment-based systems like this that are of different configurations. You are limited to some degree based on what makes sense from a shipping perspective for types of systems, and on the smaller ones, you can actually scale them down. So there is a way to make work a lot of different system configurations by either having a multiple container options or by using different scale ones. But there is also, to a degree, a finite limit where you are, for example, just too big for a containerized system. And that obviously depends on the type of system you're trying to build. If you're talking about, say, like a pH neutralization system, which is what we're talking about now, anything probably over 300 GPM is probably starting to scale out of the idea of being at least a single containerized system, but potentially can go to more like multiple containerized systems. So this is just another example here, kind of showing you how they're actually building these types of systems. This is obviously, more of a. This is what we more traditionally see. Instead of seeing multiple containers, you try to put it all into one large container. And this gives you the ability to basically have a single serviceable unit that you're monitoring only the single, really only the single point here. And there can be a fair amount of space in these units just for access for things like chemicals. Here, you can see kind of an outline of the design, the access hatches. You have all the utility lighting here. You typically, you have e-stops, for example. You have emergency exit signs and lights. You have different kind of exhaust, both HVAC as well as chemical exhaust, which are tied in separately for these types of systems. This is what they sort of look like effectively. Other ones, for example, here you can see you have the side access doors. These can also have different type of hand railings up here for access to the top. If, for example, you need to access different components such as agitators and mixers, which are also located within the actual unit. How these are built, there's a lot of engineering that goes into these. You are working within a confined space and making that sort of ergonomic design, as you do it. So it's something that may not look, if you're familiar with a lot of skid process equipment, it may not look like the most conventional thing that you've seen. Obviously, you wouldn't inherently build a tank necessarily this long or this narrow. You'd go more higher, or you change that geometry. These are built and engineered to allow for that. The instrumentation, for example, here all in the front of the units. And you can see this is just one example that kind of really highlights how these are really built. Where you have two tanks, you have the access door here that allows you access between the two, the full double containment, two different style doors here, for example, for ease of removal. The access hatches are located directly above the agitators here. This is the kind of engineering that goes into making these, the type of equipment that, not, people think a containerized system, it goes outside, you use more as like a temporary system. These systems are built to last the full, 25, 30-year lifespan that a traditional, pH solvent, chemical, RODI system, would truly be designed to be built to. Let's see if my last video will actually play here. It doesn't want to play. Yep, maybe. I do apologize. I will have this sent out. I think it might be because of the broadcast that we're doing. This was kind of a video sort of going through the sort of looking through the inside of this, looking at the sort of just showing one of the containers, really kind of doing a visual tour of it, and I'm not sure why it doesn't want to play. We'll have this link sent out to everybody on the webinar so they can kind of see it. But it highlights, I'll just kind of go back here and talk for a couple minutes about it. Kind of gives you a visual representation. If you were walking into the system you designed or was on your facility, what it would look like. As you walk in, the lighting, the different control system setups, the reagent fills from the outside, the safety showers, the ease of access to the instruments, the side doors, some of the different type of door types which are utilized, for example, escape style, the ones that have the roll-ups versus two doors, things like that, that kind of highlight how you take these types of, fairly robust systems that we've talked about and how they're really integrated into these sort of modular designs, the insulation, the HVAC. So I do apologize for that little technical issue, but I will have that sent out to everybody here to take a look at, and there's questions as needed. All right. So that ends the presentation. As I mentioned before, stay tuned. We'll be putting out the information for 2024. We do have some questions. We do have some time left for any questions we may have had. I know we have a bunch here.
Mark, I'm taking a look at the chat now. I don't see any questions at the moment.
All right.
I do see one here from Jason. Jason asks, "What is the anticipated service life of the container?" Which is a great question.
This is a great question. Typical service life, or the time the container will last, and again, like any structure on the outside, it does require maintenance. Most of these have that rigid, whether outdoor, paint coatings. They typically are designed to last about 20 years with proper maintenance. So they are designed to last the full lifespan of the system inside of them as well. So this is, you're not thinking about just like this is, some structure that's been used or what have you. They're not designed for this application for specifically, but in a way they are. There are people who actually take these, modify them to the design specifications that we or the client has, for this exact purpose.
I have another question here. Can Bert do a performance-based design? From Anne Marie. She asks, saving design costs would be very helpful.
Yes, and that's a fairly common thing, either outside of building containerized based systems or not. It is common to see a performance-based design where somebody says, listen, I have this application, I have this process, and I need to achieve, X, Y, Z, and that's a very common thing that we often do see. And we can certainly facilitate that, whether it's containerized design or not.
Okay. And Mark Ellison had a question about the high voltage needs and why or in what scenarios you would need high voltage equipment.
The high voltage is typically utilized because of the actual system in there. Generally the HVAC, now you can get 460 volt HVAC. A lot of the HVAC systems are not. They'll either be 208 or 120 volts. But very often it's the actual equipment in the actual system that needs that 460 volt, the pumps, the agitators, and things like that. But obviously, if you don't have that requirement, then you can adjust the voltage down for these systems.
Okay. And let's see here. Mark also asked, do you have a DAF solution? More chemical treatment, for example, pH adjustment for emulsion, etc.
I have seen DAF-based designs built into containerized systems. We don't build DAFs, but we do build chem feed systems that do support DAF systems.
Okay. And Nicholas asks, they said that they recently did some lift stations for pH neutralization and solvent waste storage. These lift stations that they currently have need to be placed in concrete vaults, but is a containerized system an option in lieu of concrete?
You can't bury a containerized system, if I'm understanding the question correctly. So that if it has to be underground, that's not going. The containerized systems generally are not a buriable solution. They can be used in conjunction with a vault for secondary containment and other features, but they're not actually buriable. For example, if that's what the question was.
Yeah, I believe they're asking, if you can containerize within the vaults.
Yes, you can.
Ian asks how you handle power distribution. I believe you had answered this before, but do you assume drilling holes in the sides of the container itself or providing exterior connections that the client can connect to?
There's typically a utilities cutout that's actually made in the system, so you don't want to put that many holes. You have a single spot where you basically drop that power in, and then all of the power is then run internally in the system, so you don't have a external conduit. And typically within the container itself, there's a single power drop, and then it's broken down through the transformers as needed to the utilities, to the lights, to the HVAC as necessary.
Okay.
And there's a segregated E-stop on there, which stops the system, but doesn't stop the HVAC or the lighting, stuff like that.
The utilities. Okay.
Correct.
Mustafa asks, in the mining industry, explosive area certifications are required. Could they consider the container itself as an explosive safe area? Therefore, the design of the internal equipment would comply with the safe area instead of explosive.
That's good to know. We've done work. I've done some projects in the mining industry, and that certainly would be a good feature for containerizing systems. If you can move that equipment out of the hazardous area, that's obviously hazardous. Is obviously additional equipment, additional cost associated with that.
Okay. We have another question from Mustafa. Does adding a hatch on top of the container invalidate the ISO certification of the container itself?
No.
And then editing it. Okay.
No.
Slava asks, they've noticed many containers that have T flooring. Are the containers that we offer, do they use T flooring, or is that added on top of a plywood floor?
It's typically added on top of a plywood floor. We never use plywood floors in the actual systems themselves. It's not conducive to the type of systems that we build. So the flooring is generally a different style. And actually, majority of the time, a lot of our systems actually have a grating or other type of flooring installed over that, so that you actually have some level of base containment or trenching in the system. One of the big questions that we get often is containment. Obviously, if you put this thing outside and you have all these fluids in there, you may have double wall tanks and stuff, but for spillage, you do often have some level of actual grading associated with that. So you have trenching in the system as well above that.
Okay. And I believe that's all the questions that we have right now.
All right. I want to thank everybody for joining us today. If you have any more questions, my contact information is available, or you can email the people who set up this webinar, and we can answer any additional questions. I want to thank you all for joining, and we'll be sending out some poll questions for your feedback. Thank you very much.